Hey guys, so this is the second example in 4.2 that I want you to know about. So in the first example, I forgot to label it as the first example. So please make sure you go back to that video and when you're taking your notes on it, you label as example 1. My bad for that. But now we're going to go on to example 2. And example 2 is a little bit different than example 1. This is the reason why I wanted you to see it is because in example 1, variable your variable was on the left side of this inequality. And now in example 2, your variable is on the right side. And so I wanted to give you a look at each type of thing. That way you can kind of see that there's no difference when we solve it, but also that I am going to give you some tips and tricks at the end of this video to help you graph, which hopefully you'll like. So here we go. The first step is always the same. So the first step in this example is going to be t-chart, just as it was in the just as it was in the first video. So we're going to take this and we're going to bring a dotted line down it. And again, we talked about in the first video that this dotted line serves for two purposes. The first one is it's a placeholder for our inequality symbol, which is less than or equal to. And the second thing that it does is it acts as a line of symmetry. And we talk about a line of symmetry being whatever you do on one side, you have to do on the other side. So this is two purposes here: a placeholder for our inequality symbol, and whatever we do on one side, we have to do on the other. So it serves as kind of a two-purpose reminder here. So then we're going to move to our second step, and our second step is we need to figure out, remember, order of operations, we start with parentheses, which we have none of, and we start with exponents, which we have none of. So I'm going to kind of break it down a little bit more in this one. Parentheses slash exponents. So we don't have either of those two, so we're just going to move straight along to step 3. And step 3 is going to be to look for addition. Ooh, that's not an A. Addition or subtraction. So we look at, and we always look at the operation that's being done to the variable, so this operation. And we say to ourselves, okay, is that addition or subtraction? Just like we're supposed to do in step 3. So we're identifying the operation as addition. Then we say, okay, to solve, we need to use the opposite operation. So the opposite operation from addition is subtraction. So we're going to subtract on the right side and then subtract on the left side. And you always want to subtract the number that's being added to the variable. So in this case, 14 is being added to the variable. So that's the number that we're going to subtract from both sides. And again, to check to make sure that we're doing this right, we should be able to take the number next to x, which is plus 14, and take the number that's under x, which is minus 14. And when we subtract them, you should always get 0. So 14 minus 14, 0. I know I'm doing this problem right. So now we can continue on, and we can draw our evaluation line. So we know that the x is going to come on down for the ride. Hey, just saying, first try this time. So we say x. Ooh, that's on x. So we say x. And then we talked about 14 minus 14 is 0 plus 0. This dotted line is a placeholder for our inequality symbol, less than, or I guess in this case technically it's greater than or equal to if we're reading it from right to left. And then 13 minus 14 is negative 1. So now we could say anything plus 0 is itself, so x greater than or equal to negative 1. And so that is the solution to this inequality. But again, we can't only solve inequalities, we also need to graph them. So like we said, we can't only solve inequalities, but we also have to graph them. So in my last step here, I'm going to graph. So I'm going to draw my number line. -1 is in my solution set of my inequality, so I know that that's going to go in the middle. To the left of that, I'm always going to do 2 numbers. And to the right is going to be also 2 numbers. So now that I've started, I notice that again, 0 is in, or could be a possible solution. So I'm going to substitute 0 into my inequality and see if it makes it true. So is -1 less than or equal to 0? 100% true, which means I'm going to take the marker tool and shade in. Yep, I was right. Shade in the right side here. And then again, we talked about open or closed circles. So in this case, we have symbols here like less. Ooh. We have symbols like less than, greater than, and that's open circle. And then less than or equal to, or greater than or equal to, and that is a shaded circle. So we're going to have a shaded circle, and we put it right on -1. I'm going to add a little bit to my, I'm going to add a little bit to this here, just so it's right on top of the circle. Okay, and then I told you I would give you a cool tip or trick at the end of this video, so here's your tip or trick. If the variable is on the left side of your solution set, so for instance, x is less than 1. And I'm actually going to scroll down a little bit so this doesn't interfere with anything we did. This is just kind of a side note. So I want to give you a quick side note here that you guys might enjoy. So whenever your variable is on the left side of your solution, you can always graph based upon the direction that this inequality symbol is going. So what I mean by that is if I took a dashed line and I made an arrow out of it, this would be pointing to the left side, which means that you can shade. Sorry, I need an open circle here, which means that you can shade to the left. And if you plugged in 0, 0 is less than 1, you know that that's true. This side note, which I just noticed didn't have an E in it, it was side not. Go figure that one out. Side note, that always works, but only if the variable is on the left side. It only works if the variable is on the left side. So if this is a method that you're interested in, please make the note. It only works if the variable is on the left side. Is on the left side. It doesn't work if the variable is on the right side. For instance, the solution that we had up top was -1 less than or equal to x. If you tried to graph this using that same method, we put -1 in the middle. It would be a closed circle because of the less than or equal to. And then if we drew an arrow here, the way it was, it would tell us to shade to the left. But we know from what we did up top that we have to shade to the right. So it does not, this method does not, I repeat, this method does not work if your variable is on the right side. However, you can rewrite this inequality. Instead of being -1 is less than or equal to x, that is equivalent to x is greater than or equal to -1. So -1 is less than or equal to x is equivalent to x is greater than or equal to -1. Now that my variable is on the right side, I can use the method. And I can make an arrow out of here, and I know that my arrow is going to get shaded to the right. Okay, so just a heads up for you that that is a side note that works, but only if the variable's on the left side.